My name is Schaefer.
I'm Gunnar Hillert.
So today we're going to talk about Spring Batch performance tuning. Basically, the majority of it is going to be introduction to Spring Batch. How many people here have used Spring Batch? Okay, cool. I know Wayne does. How about in terms of Spring Batch, how many people have worked with the scaling options? Okay, 1, 2 people, cool. I know you did, Wayne. All right, so today we'll start off with kind of we're basically going to just do a quick introduction to Spring Batch in case anybody needs to get up to speed. We're also going to talk about Spring integration. We're going to talk about Spring Batch integration because Spring Batch integration and Spring integration itself play into at least 2 of the scaling options that are part of Spring Batch. So we'll kind of give an overview of that stuff. And then basically inside the scaling Spring Batch section, we'll do a couple demos. They'll basically be taking a single-threaded batch application and kind of moving it through the different scalability options, whatever, going to multi-threaded and then off to remote partitioning and remote chunking. And then we'll talk a little bit about Spring XD. Anybody work with Spring XD before? Nobody? Okay. We'll basically show you how you can deploy jobs over into Spring XD. Hopefully that will help out. So Spring Batch, obviously it's one of the Spring portfolio of projects, and this is the URL. You can go there. You can get some information about it. You can download it. It also shows you it'll tell you about the Git repo. You can clone that guy, and any kind of contributions are welcome. We also have a project where basically it's a community-driven project. Where you could submit any kind of things like new tasklets and things like that, whatever for Spring Batch itself, and it becomes part of a community-driven project. So basically, what kind of is Spring Batch? What does it do? And this is kind of a quote that's, it's a quote that's taken out of Michael Manella's book, Pro Spring Batch. He's one of our colleagues. I work with him on the Spring Batch team. And basically, batch processing is defined as the processing of data without interaction or interruption. So I guess that can mean a number of things. I mean, typically people may think of batch processing as just simply doing like payroll or invoicing or whatever it may be. But realistically, you can use it for anything that you want to run unattendedly. We also have a lot of options in there that will try to do automatic retries for things that may break, calling out to a web service. Like you don't want to get notified at 3 o'clock in the morning if something you just can't reach the web service. It'll automatic retry. So really, batch processing kind of goes beyond what you may think of invoicing, payroll, things like that. Actually, one of Michael's demos was a vulnerability scanner where he checked different hosts for various different security exploits and stuff like that. So, kind of go outside of the payroll realm. So I guess batch jobs in general, generally long running. They do a fair amount of stuff. Obviously, some could be quick, but they generally crunch a bunch of numbers and go long running. Non-interactive. There's no UI typically. You don't have a job UI really where you're monitoring these things. There's obviously logic for handling errors, kind of like I was talking about before, and restartability options. Say, for example, you're calling out to a web service, some kind of exception gets thrown where you can't reach it. Obviously, you don't want this thing to loop forever, go on like 50 tries, whatever. So you may just say like, I only want to try 4 times, and after 4 times, I'm going to give up, just stop. And then there's also various different like restartability options. Restartability options kind of live at the top level, the job level. They'll also get down to the steps. If you have particular steps that like need to be reran, even if the job needs to be restarted. You can configure that stuff, and then also you can tell the job, like, this will, you just can't restart this job, you can restart this job, and so on. Batch jobs, generally, they process large volumes of data. You're reading a bunch of stuff from a database, you need to, or from a file, you need to transform that stuff, you need to throw it into a database. That's one of kind of the simple things, but processing a large amount of data. It's also a little bit more than what may fit memory or a single transaction. So we'll get to this later, whatever, but there's chunk-oriented processing where you loop through a bunch of records and commit stuff on a particular interval. So basically, batch and offline processing, it's not really batch is more of an offline thing. It's not something where you kind of go to a web page and you watch the progress of the batch application run. But some examples of batch applications, order processing, business reporting, account reconciliation, payroll, right? Payroll is a pretty big one. Import and export, pretty much your typical extract, transform, and load, data warehouse synchronization. And then you also have large-scale output jobs. All those emails that you get from like your loyalty programs and stuff. This is kind of a great, usage of Spring Batch, whatever. Send out bank statements. And then we also have things like Hadoop job orchestration, which works with, for example, like the Spring project, Spring Hadoop, right? We have a bunch of we have tasklets inside of there, Pig, Hadoop, or Spring Hadoop, right? So some features of Spring Batch, transaction management. It's obviously one of them. Chunk-based processing. We'll get into a little bit more details about like what chunk-based processing is a little bit further. As far as configuration, you have the normal schema-based approach, which I kind of find to be pretty succinct and nice. And then you also have Java config support. You can build your steps, you can build your job, you can do it in Java config. There's also annotation support. Annotation support is mainly used for like callback scenarios for like listeners and things, but you just don't build up an entire job using annotations. Start, restart, skip capabilities. If you're running through a file and you start realizing that a bunch of like records are broken, you could say like, give it a skip limit of 20. After that, you realize that like, this data file is just kind of broken. Skip over it, and then the job will stop, and somebody could take a look at it, fix it up, restart the job. It's also based on the Spring framework, so everything that you kind of love and know about Spring in general, dependency injection, transaction management, all the stuff that comes along with that, you obviously get the benefits of. Spring Batch, as of 3.0, we fully support JSR 352, so that's the batch applications for the Java platform. So if you want to write your jobs using the JSR 352 spec, we fully support that. So just some general concepts here. So in Spring Batch, underlying, I guess to start it, you have a job repository, typically a RDBMS database. And inside of there, when you're creating your stuff, you basically have a job. A job will encapsulate steps. Inside of steps, then you have some kind of chunk-oriented processing. It could be a tasklet, it could be a full chunk-oriented processing thing where you have a reader, a processor, a writer. And then obviously you have items. Items are things that are being processed. You take some items in, and then you process them optionally, and then you write those guys out. So basically inside of here, we have a job launcher. He kicks off the actual job, right? And the jobs contain the steps inside of there. So this graphic's a little bit off here. Everything says 1-to-1, but the item reader and the item writer, those are required, and then you have an optional item processor. Job repository is your basically the data that's being stored, or the metadata that's being stored in your database, and that's basically all the info about the running job, the step executions, how long that they took, how many items were processed, how many things were skipped, and so on. And that could be viewed either directly through a SQL tool, or you can write something, or we also expose various different programmatic ways to get this information. And then also we support repeat, retry, skip, restart for the jobs. So chunk-oriented processing. So basically with this, we're going to read a bunch of data, and we're going to basically write out the chunk within a transaction boundary. So we may say like our commit interval may be, 100, right? So we'll go and read a bunch of data, and then we'll pass that stuff off to a processor, item processor, and then the item processor will do whatever it is that you may want to do inside of there. An item processor, it's generified. You can take in a person object, and you can return back a different type of object if you need to do some kind of transformation in that way, or you could simply just modify the object that was passed in and return it. You can also just simply submit null, or like return null if you want to skip that particular item. And then you have an item writer, which basically writes out that chunk of items to whatever the underlying thing may be. It could be a database, it could be a flat file, whatever your stuff is. So JobLauncher, this is pretty much straightforward here. You have a client, and then you've got the JobLauncher. So client is either your shell script or your programmatic way of starting this batch job. and then you're going to launch the job. The job launcher interacts with the job, and then obviously all the business logic and everything that's contained inside of that job will run. And then you have exit statuses, basically. Did I complete? Did I fail? Then you can also modify different exit statuses to have custom ones. You can also, based on the outcome of the job, you could change like the, for example, like a process exits and an exit with 1 or 0. You can map different things, map different codes, whatever, and have it come out to be like a 4, and that could be a particular meaning for maybe a schedule that's going to pick that up after, where you're going to do some kind of process checking. Say like, okay, well, if it came to 4, maybe we need to go run something else instead. If it was successful, then maybe we kick off another job or do something else from there. So we were talking about item readers and writers. Out of the box, we support a ton, well, we provide a ton of different item readers and writers. Typically, when I'm working with Spring Batch, I don't write a whole lot of item readers or writers because we have so many of them that kind of cover a lot of stuff. So for example, like we have a flat file, reading and writing, XML, multi-file input. So we can basically, if inside of a step, whatever, if you have a bunch of different files, they have the same format, maybe you split them up, we can read them all in at one time, and then we can process those guys. There's obviously a database item readers and writers, JDBC, JPA, so on, JMS, AMQP, email, implement your own. Very simple to implement your own. Item processor is an interface, item writer is an interface, and one method basically you have to implement, and there you go. So this is kind of pretty much a simple file load job, but it kind of boils down to the most basic of what you may do with a Spring Batch application. You may have a file, and you need to read that file, which we provide built-in readers. And then you may want to optionally process that file. So each record that's coming through, whatever, you may want to look at that stuff and say, for example, like you get a whole bunch of it's people inside of that record, and you need to uppercase each one of their names inside the processor. You can uppercase that guy and then pass it off to the item writer, right? So modify the object or create a new object, whatever, and return that back. And inside the item writer, you're writing out to a database in this particular situation, and then basically you write out the uppercase name. So that's kind of one of the more simpler examples of that. The job repository, we kind of talked about before. Basically, there is some kind of data storage that happens under the covers. We're storing a bunch of different things inside of there. Each run, obviously, will keep information about like when it started, what the current status is, what the exit code is, and various different things. It could be used in there for metrics. It could be used for timing. And then also one of the more important pieces too is what is the current state of that particular job? Did it fail? Is it unknown? Did it succeed? And then when you go to restart that job, providing you pass in, for example, like the same job parameters, we could basically detect and say like, okay, well, a job ran with these particular job parameters and it failed, and the job says that it's restartable. So, okay, let's start that guy back up, and then we'll restart that actual job, and then we'll go through all the steps. And as long as each step, whatever is restartable, we'll process that particular step. So the underlying data store kind of gives us all that metadata about what's going on with those particular jobs. So that's kind of the overview of Spring Batch in a nutshell there. It seemed like a lot of people have used it. Any questions so far? Okay, so the next section that we're going to talk about, we're going to go through Spring integration. Spring integration kind of plays a fairly decent part in the scalability options when we're talking about like out of process or multi-process scaling options. We use Spring integration to do that communication. So hand this off to Gunnar. And,
all right.
There you go.
So looks like most of you have used Spring Batch. Who has used Spring integration? A little less, 50-50. So just give you a quick overview. Basically, we live in a world where everything needs to be integrated. There's stuff on disparate systems, and you need to get a hold of it or different application, and you talk to each other. And historically, we had like a couple of different integration styles, like file transfer, you share database, remoting, or messaging. Spring integration is a messaging type of framework, and you basically pass, data through channels between various adapters. in that regard, we kind of like also, in terms of use cases for Spring integration, we usually have, like you can use it for just integrating applications. You can integrate it to get stuff from remote systems, like if you need to go from FTP servers or remote customer sites, getting information, web services integration, etc. However, you can also use it as almost like as a library for inter-application integration. So kind of like to componentize pieces within your application, you can use Spring integration for those use cases as well. A common pattern for Spring integration is always retrieve, parse, transform, transmit, kind of like, in a sense, similar to what Spring Batch does. So there's a little bit of conceptual overlap between what Spring Batch does and what Spring integration provides in terms of, you're getting stuff, you transform it, and you put it someplace else. Typically, what I would probably say is that that in terms of when to use which, so that's kind of like the point that you have to make a distinction. So if you have, if things are important like restartability, error handling, etc., or that you're reading large chunks of data that may not fit into memory, Spring Batch is certainly a really good use case for that. Conversely, if you have small files that you need to process, maybe using Spring Batch might be overkill, and you could just go with Spring integration. They also work both very well together. If you have Spring Batch applications, and we show that later in the talk when we're talking about Spring Batch integration, that you can also use both frameworks really well together. And we also basically demonstrate that in Spring XD itself, which is literally kind of like a unifying platform for Spring Batch and the underlying Spring messaging that Spring integration provides. Read that book, Enterprise Integration Pattern. It's probably not an afternoon read. It's a fairly substantial book, but it really details all the concepts in what enterprise integration patterns are, of which Spring integration is an implementation thereof. It also provides an icon library, so if you need to model your flows, that gives you a little bit of support there. Spring SDS also has support for that to visualize flows, and
SDS also has some kind of they have batch modeling as well. Right?
I think so. Yes, there's also batch visualization in SDS as well. IntelliJ also has support for visualization, so good from that side. All right. Well, Spring integration provides an extension of the Spring programming model to support the well-known enterprise integration patterns. So that's kind of like probably the big takeaway for Spring integration is that while we provide all those patterns, we don't really, within the framework itself, we don't reinvent the wheel in terms of what is available. So we kind of like use whatever the entire Spring portfolio has to the fullest extent, be it like Spring Data or whatever the core Spring framework provides. So we kind of like from scheduling to all those kind of things, we reuse that quite a bit. And also provide a whole bunch of adapters. So in a sense, similar to Spring Batch. So we have a whole bunch of adapters to, for retrieving of data, for processing, to integrating with different systems, be it your FTP server, your local file system, emailing, different backend systems to need various data transformations. So you can do that.
Really, for the most part, between the adapters that come with Spring Batch and the adapters that come inside of Spring integration, I don't know if anybody's really written a whole bunch of custom ones, but out of the box, yeah, so, sorry, I guess it's a little bit low. Yeah, so between the adapters that are inside of Spring integration and Spring Batch, you pretty much be able just to write whatever it is that you need by using what we provide. So I really think that we kind of provide a whole rich, array of different integration, points. So.
Yeah, and On the flip side also, though, you can, like, Spring integration also provides generic gateways, for example. You can hook those into your own application. So you can inject a channel or whatever directly into your services, or you can just use abstract, for example, just a generic gateway, which is just a plain interface, which will then trigger Spring integration processing on the back end and put that into the messaging flow. All right, if you want to play around, there are plenty of samples on GitHub covering all kinds of things, from like simple hello worlds to just basic demonstrations to fairly complete applications. So if you need to play around with Spring integration, go there. And that's a very, very high-level overview of what Spring integration does. And we cover it a little bit more when we go into Spring batch integration, which, oh, wait a minute, I do that. So Spring batch integration was, until recently, a somewhat hidden project. It was kind of like, it was like buried deep. I mean, you heard like Golem down there in the cave, and it was part of Spring batch admin. I started writing documentation for it because there was literally nothing on that as well. And it eventually, was it this year, last year? It finally got moved over into Spring batch proper. So it's now part of the core framework, and there's fairly decent reference documentation in the book, in the reference doc as well.
A couple of months ago, it was moved over. It's still a module, so now it's a little bit better visibility inside of Spring batch admin.
And it provides basically various integration points that help you run batch jobs in a more flexible manner. One easy one, for example, is that, you know, in your when you have your you're running your standard jobs. You have your job runner, etc. You just start your job. But what happens if you have different sources of data? Let's say you have one main source where your flat files or whatever your source of data comes from, but you may have a one-off. You might want to, hey, I need to drop this one file over here and have Spring batch process it. So basically, that's where Spring integration comes in handy, is that you can kind of like decouple the processing of batch jobs from where the data is coming from. So you can basically use the routing capabilities that Spring integration provides to get the data into Spring batch. And so you can basically trigger batch jobs through messaging itself. And so we provide support for that. We have an adapter for providing or generating this JobLaunchRequest, which we then allow Spring integration to trigger the batch jobs through the job launcher. That's how kind of like the JobLaunchRequest looks like. You basically get the message in where you have your file, for example, or it could be any other piece of triggering point or mechanism that you want to use to start your batch job. You build your JobLaunchRequest, and that will then become another message that will trigger the batch job. Job launching gateway, get the request channel, payload is the job launch request, pass in the job launcher from Spring batch, which will then trigger the job execution. Another way to use Spring integration with Spring batch is to use informational messages. So Spring batch is, you can make it rather chatty. So of what stuff you want to get back on the various levels of, basically of just at the job execution level, you want to go down to the, the listeners on the chunk level, down to the item, all the way down to the items, get various feedback from there. And often it might be useful to just like decouple that whole, how those messages are handled, for example, from Spring batch itself. So that's certainly one scalability point there, that you can, if you have those events happening, that you just pass those in asynchronously into Spring integration, and then let Spring integration handle whatever you want to do with those, with that pieces of information, be it like inform, people if some errors happened or if some other state changes happen within your batch processing.
Even kind of from the slide, for example, here, whatever, where we have the email adapter. So, if a job is running, rather than rolling your own code to go and send off an email, I think Spring integration really provides those nice little adapter points, whatever, where basically inside of your listener, whatever, the job finished, you want to say how long it ran for, whatever, just fire off a message to Spring integration, and we already have Spring integration already has an email adapter, and your code is pretty clean in that respect. You don't have to duplicate what's already there. Just use Spring integration.
So right here, for example, we have like just as a quick code example, like we have a batch job defined, importing payments, etc. And then basically we define like notification listeners that will then, in this case, refers to actually a Spring integration gateway. So as I mentioned initially, you can in Spring integration you can define basically just plain interfaces. You basically provide methods on those interfaces, etc., without providing an implementation. But Spring integration can basically use that interface to then basically trigger messages to specific channels and basically route based on what methods you trigger on that interface or want to invoke to those various channels to send, for example, an email or something else. We also have a quick demo on this stuff. That's in the next session, section. And now we're talking about scaling Spring Batch.
Okay, so, all right. So in this section, manually we'll look at different Yep, how's it going?
Oh yeah.
Sorry, I wanted to ask a question before we move on.
Oh yeah, absolutely. Sorry.
Yep.
And I'm a little nervous about asking because it might just betray my lack of understanding, but I'm going to try anyway.
Go for it.
So we work with Spring Batch and Spring integration. I started a job. I think one of the places that I get messed up is, so I had a Spring Batch job that is essentially reading data from a database, and it's doing it in a multi-threaded mode, and then it needs the aggregator pattern. So what I'm actually doing is I'm aggregating into Mongo documents, right? I'm collecting a bunch of stuff and then sending it to Mongo with the documents complete. So I recognized it as the aggregator pattern. Spring integration has a built-in message aggregator. And I was like, hey, that would be a great thing to use. But you can't actually use it because it uses the message paradigm, right? That's not, unless I import it. So I guess what I'm trying to ask is there are tools in Spring Batch that I want, and tools in Spring integration that I can't kind of get them to go together. What do you guys see as the boundaries? Like Spring Batch, what do you see as the boundaries, I guess, between the two applications? Or are they really kind of coming together as a unified?
We could probably take your use case and take it offline after, but as far as the integration pieces, I mean, most of the communication is done through gateways, right? I mean, you're going to call out to Spring integration from Spring Batch through like a gateway, right?
Yep.
And then kind of kick off that flow that's there. So we can take a little bit, yeah.
So kind of like probably like the main takeaways from integrating Spring integration, Spring Batch is probably that you can use Spring integration to basically kick off Spring Batch jobs. You can then call Spring integration flows from within Spring Batch. There's also a couple of other integration mechanisms, not just informational messages, what I mentioned, but also basically to do to kick off asynchronous processing from within Spring Batch itself, and then basically you can also use Spring integration to kind of like to continue the processing once the job has been finished, etc. So it's kind of like but I think, to some degree, once you're in the core batch processing, that's somewhat Spring Batch specific. So so that's the also the ongoing efforts with Spring XD is like how can we more unify both Spring Batch and integration, because there's similarities, there's overlap, but it's still like, since they're also like historic code bases, right? So they're kind of like distinct projects historically to kind of like bring a bit more together.
So the way I ended
Okay.
So
Okay.
it stopped me from doing that, but I just felt kind of awkward for
Right. Right.
Let's talk afterwards. Maybe that might be good. We're always looking for contributors, so that might be.
Yeah. Take a look after. That works for you. Okay. Yep.
Might be a particular reason why you guys did this, but I saw, kind of a transformer that we were using to call a batch out for this specific reason why. We could use a gateway also, correct? In that scenario when we were calling that batch out from Spring integration.
Yeah, you could probably certainly call, I mean, a transformer is basically just, it's somewhat similar to what Spring Batch has as a processor. I mean, it's basically like you're transforming one thing into another. So you can certainly use that to also make an outbound call. I mean, there's certainly also similar components within Spring integration that where you wouldn't necessarily have to drop down to Java code bases like this, like a content enricher, for example, that can do similar mechanisms of like you have your flow, you may want to make a call out, go back, continue your flow processing. But yeah, that's certainly possible. In fact, that's kind of like how you would start the Spring integration flow to some degree, right? You basically have to build the JobLaunchRequest. So we don't necessarily know exactly what your data is that comes in to populate your JobLaunchRequest object. In Spring XD, for example, we do a little bit of assumptions that if it's a file, kind of like do a little bit of automatic generation of that request. But technically, yeah, it's just a transformer basically that makes that happen.
And just to answer the previous question, I guess there is an aggregating item reader that can be used for aggregation as well. And that's how we solve that problem. We use an aggregating item reader to do our aggregation. Yeah.
Okay, so
Which is definitely.
oh, thanks. Yeah.
Okay. Anybody else? Okay, cool. So we'll move on to scaling Spring Batch. In terms of scaling options, there's basically it comes down to two things. You can run inside of a local threaded type thing, or you can go multi-process, so single process, multi-process. Inside of a single process, we have multi-threaded steps, so spawn off a new thread for each guy. We've got parallel steps. Basically, they can run together as long as they don't have anything to do with each other. They can work separately, but at the same time. And then we also have local partitioning. In the partitioning scheme, we kind of have a local thing, which will run in threads. And then we also have remote partitioning that will run through some sort of middleware and do the communication that way. And then we also have multi-process. So multi-process would be remote chunking and remote partitioning. So in remote chunking, we're going to basically send out chunks of things that need to be processed through some sort of middleware. It could be AMQP, it could be JMS, whatever it is that you like, as long as it's durable storage there. And then remote partitioning, where we're just going to basically send out of a range of items, and then we're going to, on the remote side, they're going to be basically a full step implementation. So you'll have a reader, optional processor, and then a writer that will take care of handling that stuff. In the remote chunking piece, the reading is handled basically by the master side, optionally processing the slaves that are running on the remote side. They'll do either writing or they'll do processing and writing, kind of up to you. Right now, well, in the demo that I'm going to show you, 3.10 snapshot for Spring Batch. I put together a kind of remote chunking was one of those things that's kind of a pain to set up. So there's full namespace support now for remote chunking. Right now, it's just obviously not a release version, but it will come out in 3.10. But if you want to use it, you could build against the snapshot version. Also, asynchronous item processing support. We have AsyncItemWriter, AsyncItemProcessor, and those will wrap your item processor and item writer implementations. Basically, the processor, it'll hand a future to the writer. Whenever the processor's done, the writer will go and write out the completed tasks. All right, so single thread. So this guy takes a little while. If I can figure out how to use. Okay, so for the first couple demos, what we're kind of just they're very basic, and obviously that they're published. I kind of like looking at samples that are kind of succinct, do one particular thing, which is demonstrate the scaling pieces. You can get this code, you can run it. You do have to download a data set. Everybody likes cats, so there's like 800 megs of cat images. And basically what we're doing here is we're going on the assumption that we have users that have submitted a bunch of cat images, whatever, to our mythical website. And basically those cat images, the paths, get stored inside of a database, and then on the file system, whatever, we actually, that's where we write out the actual images that need to be processed. And what we're doing here is just a very simple resize of the images. So we'll read from the database these user submissions of these cat images. We'll read them from the file system, and then we'll resize them, and then we'll throw them out to another directory and get a nice little 200 by 150 cat image. So the single-threaded guy, he takes a little while. All of these samples are going to run on my local laptop. I'm kind of weary about network performance sometimes, so rather than giving you something that breaks and doesn't work, maybe a little bit slower, and we don't have multiple slaves all over different networks, but it'll at least work for you. So first we'll look at the single-threaded, and since he takes a while and it's boring just to look at the output of what's running. We'll kick this guy off and let him run, and we'll look at some code quick. I'm not really sure why IntelliJ warns me about all this weird stuff, but I'll just say okay. All right, how does that look so far? All right, so basically what we can kind of flip through some of this stuff real quick, whatever. Inside of, so it's a typical job. We have some domain objects. Basically we have an image submission class, whatever, which is just going to model like what we're reading out of the database. And then we have a processed image, just kind of representing that guy. And then we have a listener, basically just timing how long the job took to run. Then we have a processor, right? This is what we were talking about before. Kind of it's an optional piece, but obviously in this case, we want to, in here, every image that we're reading from the file system, we're going to take that and we're going to resize the image, okay? Once it's resized, then we'll pass it off to the ItemWriter. It's pretty straightforward so far. In terms of like tasklets, we just want to clean out the directory. So typical thing, whatever is, if your job's running, you got some data hanging around, whatever, maybe you want to make sure that directory is all clean for, so you don't reprocess things. This is a simple implementation of what's called a tasklet. So a tasklet kind of runs in the same, well, we'll look at the schema, but kind of the same thing. It's not chunk-oriented process, but a tasklet is used when you kind of need to do like a one-off task. For example, cleaning out an images directory. And then we have our writer. Very simple implementation of this guy here. We already know it. We know the path, we know the format name, and we're just going to iterate through all of those processed images, and we're just going to write them out to the file system. Pretty straightforward. Then we have a simple job runner class. He's just going to execute this guy. So really, across the board, all of the samples are pretty much they all contain pretty much the same code. It's all doing the same stuff. So we're not going to review all of that, for each sample. There may be, in some cases, for example, the ones that have slaves, master-slave pattern. We may not need the domain objects over on the remote trunking like a master piece. So we break down the code base a little bit. So the more interesting piece here is your actual application, right? So I guess when you first start writing a job, you may just go along and just say, okay, let's create our job, let's do our listener, let's do our cleanup tasklet, and then our process images. Okay, well, we got like 4,000 images here, so I guess the first thing to do is see how long it takes. Well, it kind of took 2 minutes and 49 seconds, to process all of those images. And so now, obviously this is a small example, but if you have like 100,000 images to process or whatever it is that you're doing, whatever, that would obviously go up, and that just may not be acceptable. So in the single-threaded model, this is your typical batch job. We're not really logging out a lot of interesting stuff here because we're basically just saying that we're writing the 500 images, and in this particular case, We have all sorts of little fuzzy cats. Okay, excellent. All right, so that's that. So now you say, okay, well, 2 minutes and almost 3 minutes really isn't acceptable to process 5,000 images. Okay, so the next easiest thing to do is basically use our support for multi-threading. Okay, same code base. The only thing that we're going to change here is basically putting a task executor on our chunk, right? So we have in our process images section, we have a tasklet, and we're saying use this task executor, right? And the task executor, we're just using a simple async task executor for this demo here, just saying a concurrency limit of 8. And basically what that's going to do is it's going to read in chunks, and there's no guaranteed ordering or anything like that, whatever. So it reads in a chunk of data, whatever, and it will give it off to a thread, do its processing, and then another chunk, and just keep on spawning them out that way, right? So when we use that guy, now you also have to you also have to make sure that anything that you're using is thread safe and so on. So for this guy here, we'll basically go from 3 minutes down to 43 seconds. It's going to show you the same output there, whatever. I should probably start these jobs and then talk about the code, but just kind of blaze through these guys, and it takes about like 43, 50 seconds. So if you can get away with just throwing a task executor on your stuff, it kind of reminds me of that song. That's probably like your first step there. And if that gives you performance gains and they're acceptable and all of your code is thread safe and everything works, that would probably be the first step to kind of investigate. So as that guy's running, well, let's let this guy go. Okay, so obviously we went from almost 3 minutes down to 46 seconds. Pretty acceptable there. So that's another option. Let me start these guys. So another option, which is kind of similar to using a task executor here, we'll run this guy, get him started. It should take approximately the same time. In this particular case, so same code base and everything, as I mentioned before, a lot of this stuff is duplicated, but the point is that if you want to play with the samples and you want to, modify them for your own use and everything, each one of these guys is self-contained. There's no dependencies on other things. They're kind of pretty clean out of the box. So in this particular case, what we want to do is we want to use the, so when we were talking about before, Spring Batch integration, some of these, as we go along now with these, we'll be talking about Spring integration, Spring Batch integration a little bit more. These classes come out of that project. So for example, like the AsyncItemProcessor, he's basically wrapping your item processor, the item process that you have, right, as the delegate that's here. And he'll basically create a future, and that item processor will go and do whatever it is that it's doing. In this case, it's resizing images. If anybody can't see the whole text, just let me know. Resizing images, and then we have our writer, right, which is the same guy as it was before, and we're just wrapping that with the AsyncItemWriter. So the processor goes, he creates a future, and then he'll pass the stuff back to the AsyncItemWriter, and whenever that processor's done, the ItemWriter will write the stuff out. So as you can see, like you take your job, and there's not really a whole lot of modifications that you have to make, so you can kind of incrementally improve your job with very little changes. So if we look at this guy, or the outcome of this guy, 49 seconds. So it's roughly about the same thing as the multi-threading guy, but two different options that you can use. So moving on a little bit further from there. Excuse me?
Last example, we used the async task executor also. We use both. Yeah, that was also async task.
Right.
You use both the async task receiver and the async item writer.
Right. Yeah, I think this may have been, we can probably take this out. This may have just been a copy-paste error on my end. You don't need the actual, well, the task executor is running inside of the image processor. So yeah, there may be some strangeness that's going on there, but this is not like required here to use that particular pattern. So it really can come out. Good catch on that. Okay, so we've talked about single-threaded, which would you'd start your job, and then we've talked about multi-threaded, then we've talked about async processing. So I guess the next one up, whatever that we can talk about here, we haven't really been keeping with the slides. It's not really the end of the world. Single-thread, multi-threaded, right? Asynchronous processors. All right, so remote chunking. Talk about that guy next. So with remote chunking, this is kind of a situation, I mean, this is like a typical job, whatever, where you have 3 steps in your job, right? And step 1, you're using an item reader, item processor, item writer. Step 2, maybe you have a lot of additional work, kind of like what we're doing here with processing these images, and we want to farm them out to a bunch of nodes, external nodes to do the processing, right? So remote chunking requires that the writing, it's writing and optionally processing, or a mixture of both. The reading is done from the master, and the nodes will do the either processing or the writing. And that's what we got going on in step 2 here. And then step 3 is kind of like your typical task, or your typical step that would do item reading, processing, writing. So when we ship this stuff off in remote chunking, so you can see like step 2A, step 2B, step 2C, the reader probably shouldn't be in this graphic here or whatever, but in our particular demo, we're chunking out the processing work, and we're also processing out we're chunking out the writing work, right? So step 2, we have basically an item reader, and that's going to go tell us like what images that we want to go and process. And then on the slave sides, they're going to actually do the resizing, which is done inside the item processor, and then they're going to write to disk, with the item writer. Previously, before, I should probably start this guy up here. So with the remote chunking sample, so I already have ActiveMQ running locally here, but you can use Rabbit or AMQP, whatever you want to use. So in this particular case, what we have is we have a slave. Okay, so now you can see in the log output here, or at least I think you can. Inside of here, now we're really starting to use Spring integration a little bit more, right? You can see in here that there's channels being created, there's JMS listeners being created, stuff like that. And on the slave side, what's going to happen is that the master will be publishing basically the chunks or the units of work that need to be completed, and the slaves are connected, obviously, through Spring integration to ActiveMQ. And they're going to basically be listening there for items that need to be processed, and they're going to pop the stuff off, and they're going to process them. Okay, so we have our slave running, for example. We can run a couple of them just for fun. Like I said, I mean, so remote chunking, obviously you wouldn't probably run like 4 different slaves on the same machine, but for the sake of network, we're going to do it all here. You would have it kind of pushed out to multiple machines, and they would all communicate through JMS or AMQP or whatever. Okay, so we've got our slave started, right? And then we'll kick off our master, if I can actually copy paste correctly. And then we'll look at the code for it. So let this guy run. All right, so in this case, our code layout's a little bit different, but we're not going to really go deep dive in here, whatever. Really, the main difference is the domain objects. Obviously, they're serialized and they're set across the wire, so both ends, kind of the slave and the master, need to know about those same domain objects, whatever. So they're just pulled out into their own little module here, whatever. On the remote chunking master side, job stays the same. So job pretty much stays the same here. You know, kind of going about doing all your normal stuff, whatever. The only thing that's different here, right, is we have this ItemWriter guy, okay? And the ItemWriter guy, I apologize for the red pieces in here. IntelliJ probably wants me to create all of these things, but not really sure what they do. So anyway, prior to batch 3.10, this is really what the new namespace provides you here. So rather than going and building all of the different objects up that you would need to, or the different configuration that you would need to for remote chunking, which was kind of confusing in some ways, now you simply you can use this namespace. And what this basically does for you here is you're saying, okay, my ID is the ItemWriter, and we're going to use that as the writer, right, which is defined up here, okay? And we give it a message template because under the hood it's using Spring integration, and we need the messaging template there. And then this little guy here, whatever, says the step, you know, like which step are we going to, which step do we want to remotely chunk? And that's this guy here. And then we have the reply channel, which is replies, and that kind of starts going into some of the Spring integration stuff. On the Spring integration side, so this really we don't know, like, are we using JMS, or we don't know if we're using AMQP or whatever, right? Because we're using the channels abstraction, right, through Spring integration. So in my particular case here, whatever, I just have a file called JMS, and this is basically where I'm configuring my ActiveMQ stuff, and then this is my channel configuration, and here I just chose to use JMS, and this is basically the configuration for it. But this is pretty much standard for any kind of like channel adapters or JMS listeners and things like that, whatever. So let's see what happened here. Okay, so obviously this is all running out of my machine. I profiled this stuff a little bit, and creating the actual images using the AWG library is extremely processor intensive. I'm not really an image guy, don't know too much about it, but most of the time is spent there. So while this has a minute and 2 seconds here, we're running a bunch of different guys going over some middleware here. On my local machine, doing the multi-threaded sample obviously ran a little bit faster. There's a little bit more overhead on here. So take it, run it in a bunch of different machines, and you'll get better results than what's listed here. But for the sake of the demo, what we're really looking at here is we kicked off a master, and the master sent out a bunch of requests to ActiveMQ, and then we have all these other little slave guys here. And this guy here picked up 1,500 images. He did his processing. He picked up a couple more, whatever. These guys picked up 1,000, and that guy picked up 1,000, and basically did their work, and they wrote it out, and that's that. After each guy completes, he reports back to Spring Batch. Spring Batch will obviously manage the expectations, or like what the outcome of those particular steps are. If it would have failed, Spring Batch would have been notified, and it would have failed and give you an error on the screen. But thank God everything kind of succeeded here, so that's good. So I know I had asked before, I'll ask again, has anybody used remote chunking? Okay, so since you guys have used this, you probably know the configuration prior. Do you like the namespace? Yeah, seems a little bit more cleaner? Okay, cool. If you'd like it to. I did the namespace because I just got bored of typing the configuration over and over. But if you want it, obviously you could submit something through Jira, or we can talk offline and get it going, whatever. So see what happens. So that's remote chunking. Now, on the other hand, we have kind of a similar scaling type thing, which is remote partitioning. We'll do a little, start this guy up first. In the remote partitioning set up all the slaves and stuff, so you need to actually have access to the database that has the job repository. Let's see if I already have it in here. So in this particular case, we'll just use HSQLDB. Again, it's running on my local laptop. You probably wouldn't want to run that in production, but Same type of situation, load up a bunch of slaves. Keep that guy for the master. We'll start this guy up here. Okay, remote partitioning, anybody use it? No, okay. All right, so with remote partitioning, again, we have a master, we have a slave. You can combine these configurations into one, so basically like the master will actually like process things as the slave would. I typically like to have everything separated out. It's a little bit more clean to me, but it's really up to you. The samples will show everything obviously broken out. In this particular case, there's no namespace support for it, which would probably be something that I would end up maybe doing. So in this particular case, with remote partitioning, you're going to have a class that basically says, for example, in this guy, whatever, we'll look at the column range partitioner. And we're going to, this is straight out of the Spring Batch samples. You can pull it out of there, you can use it from here. And basically what we're going to say is like we want to define the partition size. Basically how much work is going to be distributed over whatever we call, for example, like the grid size. So in this particular case, we're just going to go out and we're going to query the database. So if you recall what I had said earlier, under the covers when the context loads, we're actually populating a database with all these cat image paths, right? So in this particular case, with the remote partitioning, you create a partitioner implementation, and for here, we're basically saying we're going to select the min, we're going to select the max, and then we're going to do some calculations in here, basically to figure out how many different partitions that we want to have, okay? And it's based on the size of the data, and that's how you can figure out how many slaves and so on that you want to have. So that's really kind of one of the main differences, and this message channel partition handler, so we're obviously seeing it inside of here. We give it the step name, we give it the grid size, we give it the reply channel, we give it the messaging operations, just the messaging template. So some of this stuff kind of looks similar to the remote chunking piece, whatever, but this is a little bit more, you have to configure it yourself. So I think the namespace worked out pretty well for the remote partitioning. So in this particular case, like I said, we're going to just basically read from the database. We're going to say we have X amount of records. We're going to break that down to like, how big that we want the grid size so that we define it here. And then we'll split up the appropriate number of records and tell it that basically the step name is process images in this particular case here. So we're looking at the master. In this configuration here, we're not actually defining the processor or the writer. We're defining a partition. So it says for our step, we say batch partition, we give it a partitioner, and then we give it the partition handler, okay? So you have that clean separation there. Our partitioner is what we're just using as the column range type guy, but you can implement your own thing and put your own logic in there. And the partition handler is going to basically, we're utilizing this for Spring integration message communication that's there. On the slave side, it's slightly different. On the slave side, we're actually defining our item reader, item processor, and item writer, right? So in this case here, it's the same exact thing. We're going to read from, so with remote partitioning, the entire step is going to run on the remote side. Remote chunking, we had basically the processor and the writer, or the writer and the processor, depending on what you want to do. The remote partitioning scenario, you're actually dispatching an entire step to the remote guys. So you're doing your full item reader, item processor, item writer, and this is pretty much, it looks like your job, except you're changing up some of the SQL queries. You're saying with the min value and the max value, and then you're also passing in some of this, the execution context stuff, whatever, which is, this is step scoped. So when this guy goes and reads that min value and that max value, those guys are actually coming from the column range partitioner. Okay, so in here, we're stuffing stuff inside of the execution context so we can refer to it later. And that's how each step that's going to run knows basically what data it needs to process. And you can reference them through that syntax that's there. Pretty much everything is the same. your step locator and your step execution request handler. That's basically how they communicate back. So with that being said, we kind of have the same thing here, 1 minute and 13 seconds. This is our master that's running, and then we have our slaves, and kind of the same deal as what we saw in remote chunking. Just prints out how many images that were processed, and that's pretty much it. So with those guys, before we go on to the last sample, again, we have all our little furry friends resized and ready to go. Okay, so our last demo that we're going to take a look at here, I believe. We looked at remote chunking, looked at remote partitioning. So the last demo that we're going to look at. How are we doing on time? You know what time? How are we doing on time? What time does it end? We have half hour left. Okay. So the last demo that we're going to take a look at here, this isn't really, it's not a scalability option, but we wanted to kind of talk about parts that came from the Spring Batch integration piece from earlier. And typically, in all these demos right now that we've kind of showed you, whatever, is just running a jar or like use the command line job runner, whatever the deal is. But we also kind of felt that there was value in showing you that you don't have to just execute jobs like we have. So for example, like these could be cron tab to run at a particular time. We don't provide a scheduler, but jobs could be scheduled and so on. But to show the Spring integration piece, it's a little bit more dynamic. And basically what we'll do here is we will, rather than having everything kind of like statically defined and actually running the job, let me kill all these slaves before my machine goes crazy. So let's say, for example, I'll just show you the directories and stuff. Make sure everything's all clean. All right, so say, for example, you want to, you get just an arbitrary zip file of images. Probably a little naive just to process them, but whatever. You get just arbitrary zip file, and it could be anything, or it can contain any of them, any amount of images or whatever. So in this particular case, what we're going to do is we're going to launch the we're going to launch this job, and there's actually 2 samples that are kind of rolled into here. Basically, what we will do is we'll start this guy. Oops. Okay, so we're going to start this guy here, and now it's just sitting there. It's like, okay, well, what am I waiting for? Basically, in this particular demo, what we have is we have Spring integration sitting there waiting and watching a directory. It's waiting for a directory for any kind of like zip files to be stored in there, right? And essentially what's going to happen is once Spring integration recognizes that a file was put into that particular directory, it'll kick off the job, and it will pass the information over kind of to the JobLaunchRequest and that whole transformer that we were looking at before, and it will pass that information over to the job. Job will take it, and it will process it. Okay, so we'll start that, and then we'll look at some code. All right, so we could just take any random, so like test images. Let's use the big one first. Just move that guy over there, and without doing anything, you see that this is starting to go, right? So if you want to just if you have a job that processes images generically, all it does is resize them, watermarks them, or whatever it is that you may be doing, rather than actually launching this job at a particular time, you can just using the Spring integration pattern that's here, where it's polling that particular directory, looking for stuff. You could basically keep this application running the entire day. Anytime something's dropped into that particular directory, whatever, it'll pick the file up and it will start processing it. So it's it's a little bit, it's kind of more real time than actually just cron tabbing it or doing whatever. So in that particular case, let's just, while that guy runs, let's take a look at the code for this guy. So actually, as I said before, this sample kind of does two things. We wanted to kind of roll in here was the ability to pick up files and process them, but also give notification. So rather than just having like a log message printed out to the screen, obviously this is kind of a basic example, but when the job finishes, not relying on network, because I have ActiveMQ running here. Maybe you want like an email sent off and say like, hey, you know, job finished in X amount of time and I processed X amount of CAD images. You can use Spring Integrations, email support to fire off those messages, put it inside of a listener. When the job is done, it'll send off that message. In our case, what we're basically doing is just the job will run and then it'll just push a message onto a JMS queue, and it will tell you the amount of time that it was running. So in this case, whatever, we modify the job a little bit. We have our job listener. Job listener in the previous examples was just logging things out. In this particular case, we're going to actually send a message through the gateway, which then Spring Integration will pick up and will throw a message on the queue. We add an additional thing here where we're going to just uncompress images, right? Because we have a zip file, so we can't just extract images without unzipping it. So we'll unzip it, and then it'll process the images, and we'll go on. So that this guy ran. So he went through all of them, and now it's still sitting there again, right? And basically just waiting for more work. So in this case, whatever, we processed our images like before. We have some informational messages that just Spring Batch gives you just out of the box as far as like what's going on, right? We have like the input file name and all those things because they were used as job parameters. This is not very exciting, but just to show you, the ActiveMQ thing. Surprised this actually worked, because usually it tells me an exception occurred. But so that's kind of our informational feedback, whatever. So somebody could be listening to that JMS queue. Obviously, you would probably pass a little bit more informative or marked up message, whatever. But our imaging job, it ran for a minute and 50 seconds, and that's that. So while this guy's running, now again, so before we moved over images 1. Let's take images 2. There's only 3 images in this guy, whatever. But we'll take him, and we're still not changing the job or anything like that. We move it over there. Spring Integration's listening. It's going to pick it up. Obviously, it went pretty fast, whatever, because there's only 3 images in there, and it runs. And that's pretty much it. So it kind of gives you two different ways to launch batch jobs. You can run them through cron tab, automatically through the command line, or you can bring in Spring Integration and have it look on a particular directory, or whatever, SFTP, right? I mean, you can have Spring Integration pull a remote directory, maybe for like some like marketing metrics that could get like collected through like places like Eloqua or whatever the deal is. Pull those things down and then kick off the job based on that. So you're now going from just Spring Batch just running in a console or whatever on a cron tab to more of a dynamically driven kind of workflow using Spring Integration. Hi.
I see a lot of XML configuration here. Is it possible to do with annotations? Defining the beans and batch jobs and everything. You are XML code, right?
Yeah, I had used all XML to keep everything kind of concise and clean or whatever. In regards to annotations, their annotation, so the listeners, the listener could have been replaced with annotation. There are some other things that could be replaced with annotations, but and then there is Java config support for building stuff, but the annotations are mainly kind of like focused on callback type things. Okay. All right. Any questions? What's that? Uh-huh. Oh, like calling out to that? I mean, if that's from what I recall, I'm not very big on databases, but I mean that's just a command that's being executed through like your command line or whatever, right? There is, in batch, we do have a built-in tasklet, whatever, where you can call out system commands. If that's what you're looking for, you can execute a command through that, and once the step completes, then I'm assuming your processing would be done, or your loading would be done. Is that what you're looking for?
Yeah, it's like a custom thing, so instead of doing like a million inserts, you just do one copy state.
Right.
So I was just curious.
Curious about?
I was just curious if you'd ever used
Oh, no. Anybody else?
I was wondering if you had any idea on if Spring Batch admin might be replaced by the XD GUI, or like how those might be complementary or not.
I actually talk about that when I go talk about a little bit of the XD piece.
Yeah, we'll get to there'll be an admin piece coming up. If you have anything in particular, we can talk about after with admin. Oh, he was asking if you want to repeat the.
I was asking if perhaps the Spring Batch admin would be replaced by the Spring XD GUI, or just they seem to maybe have some things in common.
Yes, they do. But let me talk briefly about Spring XD. I mean, anybody that did not go to the keynotes, all right, so I guess you all know about Spring XD by now. Basically just, it's basically kind of like our unifying approach to bring, real-time analytic data ingestion, stream processing together on one side, but also have the ability to do batch processing on the other side. So, for example, also, we're always talking about big data. Spring for Apache Hadoop, that project, for example, has a whole bunch of components for Spring Batch, for example, if you need to process data that needs to go, for example, into HDFS, etc. So that's kind of like the promise of Spring XD, and consequently, we can basically deploy also batch jobs onto Spring XD, and also, therefore, also then integrate it with other streams that you may run within Spring XD. So, it basically is kind of like our, Spring XD is our kitchen sink application for everything. So we reuse, Spring integration reuses a whole bunch of stuff from the Spring portfolio. Spring XD kind of takes it to another level. So, it basically heavily relies on Spring integration and Spring Batch. It also comes, for example, it reuses Spring Shell, for example, to have a command line interface there, but also comes with the web UI for its working. And at its core, you kind of like build basically streams. So you can get basically, from the command line, you can, for example, do like HTTP pipe file is a very extremely simple stream to basically get stuff from HTTP, open up being able to receive payloads via HTTP, and then basically just copy them over into files. So it also has like a whole bunch of sensible defaults of where that data is and default values for that. Or if you want to do, do Twitter search, etc., those type of things, those are easily possible. But there are plenty of sessions covering those things. The core I want to basically just go a little bit into in regards to Spring XD is its batch processing capabilities. So, for example, you can use it to manage Hadoop workflows, and for those we rely heavily onto Spring Batch. For job state management, launching, monitoring, restarting jobs. As mentioned, we have an admin UI for Spring XD that right now has predominantly functionality for Spring Batch admin. Actually, not just the UI, but also the REST interfaces. So those are pretty much feature parity with Spring Batch admin. So the UI actually provides even more features right now than almost more features in certain regards what Spring Batch admin has. I show those when I basically show the image scaling example converted into Spring XD. Oh, here's the admin UI screenshots. So it can basically kind of like if you're familiar with the batch admin, it's a little bit more polished feeling to it, allowing you to not just deploy jobs onto Spring XD, but then also drill down into the various job details when you execute. You launch your job, you run your scheduler, etc., and then you go into the job executions, for example, drill down to the step details, etc.
Just got a question.
Yes?
Is there methods for extension for XD UI like there was in Spring Batch admin?
That's still probably a work in progress in terms of how to, basically the main work right now has been done in Spring XD, basically providing the same functionality as Spring Batch admin has in Spring XD. So eventually we would probably either to separate it out, I mean to basically find a way, and we understand certainly that there's many people use the Spring Batch admin UI for their own internal projects. So that will be probably something we still need to determine how to proceed with that. But for right now, it's kind of like tied to Spring XD itself. But for the time being, also the Spring Batch admin project is still being maintained basically. So it's not going away
anytime soon.
All right. How much time do we have? Oops, demo. I need to go to mine.
I'm pretty much done with this guy. Right?
Just the books, I guess, yeah. Okay. So let me just bring up my project. So basically what I have here is the XD multi-threaded batch project we had. Whoops, let me just zoom in there. It's basically exactly the same project itself. It should still run by itself. I had to modify a little bit how the application context file is being organized. Kind of like it's still a bit of work in progress how to make that better, that handling better in Spring XD. But basically, what you end up when you build the sample, and that's in the same repository as the other samples, is that you basically build a Spring XD module. In that Spring XD module, we have kind of like two directories at this point. One is the configuration data that contains the application context and the job definitions, etc., as well as library dependencies into the lib folder. So in this case, since we're deploying onto Spring XD, we don't need the whole kitchen sink of dependencies that Spring Batch has. We only need, in this case, we're deploying the classes we created for the sample, as well as the distinct dependencies that are specific for that job. In this case, the image scaler libraries. Otherwise, pretty much the same thing. That's the context file. We have been doing some database initialization since we need to move the file names in there. We have the batch job. I needed to get that into, give this a name of job so that gets recognized. And everything else is still pretty much the same. I didn't need to do any of the batch infrastructure configuration, including the data source. So that's all. We basically just reuse whatever Spring XD provides. So that's kind of like my context file that I have in that regard. So, and then basically once I build it, I just move it over to Spring XD. I have that over here. Here's my Spring XD installation. We have under Spring XD, I have my lib folder. Not my lib folder. My modules folder, and then I have basically a whole bunch of predefined modules, including specific for jobs. They comes with a whole bunch of jobs, file JDBC to get stuff into HDFS, etc. And then basically I have my image scaling job. I deployed it in here, config, lib, and that's basically it. Let me just bring this one up. Let me just start this guy. Single note. All right, should start up in a second. If you like command lines, there's also command line interfaces, which is sometimes quite helpful. So we always keep to also now moving forward the UI and the shell in parity. All right, things should have started up. So, almost. All right, I'm sure this works now. Yep, so UI comes up. So basically we have modules. You can have your definitions, deployments, executions. I have right now nothing in there. I have my image scaling module. You can take a look at your module itself, what's in there, what options are available, your definition file that you deployed there. And then you can also deploy your job right onto Spring XD by going down here. Click on it, give it a name, image scaling demo. We deploy, let's do this. We can do that manually. You can either auto-deploy or do that as a manual step. All right, you have the ability to make your jobs unique. So kind of like in batch, typically if you want to restart the same job with the same parameters, you can't. But if you kind of like a workaround, there's also ability to make them restartable. All right, submit. Job was created. Should show up under definitions. We can then go into deploy. That should deploy the job. If you have more complex deployment scenarios, deploying onto multiple containers, you can do that. Or if you want to do only a subset of what's available, do that. Deploy. We should at this point have a deployed job. And we can just launch it. Oops. You can also, if you want to, you can also schedule the job at a later time or recurring. Okay, launch and press launch. Has been launched. Let's see what's going on here. I had an earlier one that's right here that was completed. The current one is started. You can then basically drill deeper into the job itself. Gives you the job execution details, the steps that we have. We have the cleanup step, the process images. You see it already has like 300 writes being done, so it takes a little bit longer. We can go in here, process images, see what's going on there. Get the details for the step execution details, the step execution context, which is actually a feature that was not available in the batch admin. So that's now in here, which is kind of neat to have that additional info. And we should be almost done. Still executing. All right, but that's basically what Spring XD, what we provide from the admin UI. So it's parity what Spring Batch admin has. There will be more support coming, particular for stream processing. Eventually, I would assume we would also add the ability to deploy jobs through the UI. So that's certainly one feature that's missing from the old admin UI. So we need to get that in there at some point. But otherwise, from just a monitoring perspective, it's pretty much there. So that's pretty much what I had for Spring XD. Okay. And I don't know if you want to go back to your slides or so, but just any questions regarding XD in the meantime?
Okay.
All right. Otherwise, it's basically just, if you want to do more reading material, I think our reference docs are pretty good, but in case you want to branch out into other documentations, Michael Manella, he has his Pro Spring Batch book. There are a couple other books on Spring integration as well as Spring Batch. Mm-hmm. And with that being said, thank you so much.
Thank you.